Okay, so let me ask you, as a software developer, have you ever needed to understand code that you didn't write, or you wrote such a long time ago that you don't remember how it works? This is a common problem in software development, and if we were to be able to crack this problem, then we could see real improvements in efficiency in the software development process. And most people write code in, or at least in applications, in languages such as Java. So that's what I'm focused on here. Here is a typical stripped down example of how people write code and what the problem is. We have a field of type integer, name of the variables I, and we set it to a particular value. Then we call some method. It could be a private method in the same class or not. And then afterwards, um, we may not print the value of I, we do here, but we want to know what the value of I is to be able to understand this code. So the question I ask, which indicates the level of understanding we have of this code, is, has I changed? Let's take a look at that again. Now, it's a rhetorical question because the answer is we don't know if it's changed. The problem is this method do stuff. It could literally do anything. It could modify I. It could modify I and do a bunch of other stuff. It could do something completely unrelated. We just can't tell. What if instead we did this? We declare a field of type integer again, but when we set it to 1, we make it final. Then, again, we executed the same method, unchanged from before, and then we printed its value. Again, I ask you, has I changed? And the answer is no, because if it's final, we know for sure that it cannot change in value. So that's great. That solves the problem if do stuff is a method that doesn't affect I. What if we do want it to affect I? How could we be more explicit about that? Take a look at this. The difference here to the original is that we have, from this method do stuff, we have returned the value that we want to assign to I. So without looking inside the definition of this method do stuff, we have a better idea what this little block of code does, this method called init, what it does, just at a glance. So just to summarize those two things we did to make this easier to understand, one is we make variables immutable. Or if they are immutable, we want to make it very clear that their value got changed by making the output explicit. The sophisticated term for this is referential transparency. Let's step back for a moment and think about how to generalize this. Java, and indeed many of its peers, are imperative languages. So the likes of C, Java, C++, and many others are imperative. And what this means is we maintain some kind of data in main memory in the form of variables, and step by step we are transforming that data in some kind of that data that forms some kind of domain model, some state. So in other words, the values of variables are changing over time. That's been a typical model of programming for more than 20 20, more than 30 years. But there's a higher level of abstraction of programming called functional programming, and this has become more and more of interest to the modern software engineering community after the turn of the 2000s, in no small part thanks to Google, even though functional programming has been around since the 1960s or possibly earlier. So functional programming at its core is a functional program is a statement of relationships between input and output variables. And there is no concept of time like we have in mathematics, mathematics from school. You would say I equals j plus 1. That's a meaningful functional relationship. Whereas in imperative programming, we could say I equals I plus 1, which your math professor would tell you is absolute nonsense. That's where the functional programming is different. It reflects mathematics more closely in that there is no concept of time changing the values of variables. A variable has a value, and it's its only value, regardless of what point in time we are talking about. So Java is, like I said, an imperative language. So can we really benefit from immutability or this removal of time in a language such as Java? There's two ways to do it. There's a whole generation of languages that provide support for functional syntax, much like Haskell, which has been around a long time. So, but they run on the JVM. So languages like Scala, Clojure, Groovy, and that's great. If you have experience with those, that's progress, and we are seeing those in the industry. But for the rest of us who don't have a huge amount of time to learn these things, and even if we do just learn them by reading about them, we don't get to implement them in our daily or exercise them in our daily jobs, and that is always going to be a handicap in trying to progress in how we write code. There is a more a gradual alternative to improve our code, and that is we can freeze time. There is still time as far as the Java runtime is concerned, but we ensure that our variables cannot evolve over time. Once they have a value, it is that value forever. In other words, we've made variables immutable. At this point, that's enough theory. Let's actually look at some real code to figure out how we can make our code, similarly to the examples we saw above, some real code that we could make easier to understand through these functional practices. So I have a server that is a web server that is a single file. It's my this is you may have heard of the nano HTTP web server. So nano HTTPD is a single file web server, works very nicely by the way, that is similar in spirit to Tomcat or Jetty, but it's just what I would consider halfway between something that's realistic code and something that we can we can demonstrate these principles of refactoring our code to be more functional in nature. Let's go to our first example. Here we have a field that is non-final, and we've already seen what the dangers of fields are that are not final. So if we could make this final, then that would improve the understandability of our code significantly without having to run it. Now in this case, this field status doesn't get modified anywhere in the constructor, so that's a very easy candidate for making final. So let's do that right now. And we do get a compile error because we have a setter, but like I said, in this case we're actually not using that setter anywhere. So let's remove that. So here's this setter, which we're not using, and setters are the enemy of functional programming. So anytime you see setters, you want to try and remove them. You should only be setting things in the constructor and making them final, and that makes code a lot easier to understand. And take my word for it that there are no compile errors left, and that this web server will work just as before. Now let's take a look at another problem. We talked about not knowing what has been modified by a method call. Here's the call to this set protocol version header. We have no idea what's going on inside it, but when we go into it, we can see that it is setting a protocol version. I don't know what it's setting it to, but to be honest, that's not the most important thing we have to concern ourselves with, at least at this level of analysis. So what we should do instead is make return a local variable from the helper method. And now in the caller of this method, we explicitly set this field. And we saw an example similar to this when we had that toy example of that integer I. And this, without going inside the method, when reading it at a glance, we can tell that whatever this method does, it's setting a string as a result, and it seems to rely on this variable, which is a string tokenizer. Let's take something a little bit different. When we pass, there's a variable on line 611 called pre, and it turns out that's a map which we pass in as a parameter to this method decode header. Modifying a collection, especially that is passed as a parameter, is not good. So what we should do instead here is return the map as a parameter, in fact there are multiple exit points from this method, which is one reason why some people say do not return in multiple places, but let's just do this part. And in this case, since we don't do anything, we can just return the collection itself. Whoops. And now if we go to whoever declares this, whoever calls this, sorry, whatever this pre is, we can assign to the output of this method call. And we could go one better still by passing in an empty map as a parameter. And in one line we can see that this map gets built as a result of this method call. There is more. What would be even better is if we need to pass in a collection that is non-empty. What would be even better is to make a copy of this collection, and that collection may be mutated, but it is of no consequence to the code that follows. Or even better, use these immutable collections. Now, Guava has something called immutable map dot copy of, but in this case it's not what we want to do. Because this method is, in fact, really we don't even need this parameter. We're constructing a new map and we're returning it. So we should remove that parameter and build the map inside. And before returning, we should create an immutable copy of it. Or even out here, we can say immutable map dot copy of. And then we can guarantee that no matter what happens after this point, pre will be whatever it was at the time that we called this method. There's one more refactoring which is recommended. It's a little bit more involved, not complicated, but a bit more involved than I wish to show in this demo. It's to do with construction of objects. Specifically, in this case, we have a we created one of these response objects, and there's a lot of stuff even after the constructor that we need to populate this custom object with. Excuse me, my computer's a bit slow. So this object R of type response is being constructed partly inside this serve method on line 874. And let me just show you the declaration of that object. So we have this response object, and you can see R is initially set, after being set to null, it is set to whatever the output of the serve method is, and then after it at least in this else case, we are setting more properties on it. What we really should be doing is, instead of, when we're in the process of setting fields in it, we should really be using a builder. So R should be of type builder. Let's do that. And then this response builder, which would be initialized by this serve, and then response builder, so maybe instead of R, we should call it RB, RB.set this, RB.set that, and then eventually, when we actually want to perform logic on it, we would build it, which would finalize the object, so we can't change anything. In other words, all fields inside are final, and then we would perform whatever downstream business logic is needed. Again, I'm not going to show that because there's just a lot of mechanical activity to write all that logic. But anyway, just to conclude this presentation, let's summarize what we just talked about. Make fields final as much as possible. Make collections immutable, and use a builder pattern. And of course, referential transparency. This just scratches the surface of everything about functional programming. There are lots more good things that I have omitted in the interest of keeping this simple and understandable for those that are a bit intimidated. I recommend you read up on a book that is has more information, but is not too overwhelming. Some people can get into too much detail about functional programming beyond what is necessary for you to write good code. So I recommend this book. Not affiliated with it in any way, but it's a nice short read, so that will just allow you to deepen your understanding of it. And as for my contact details, you can get there is my email address, and these slides you can get from my website. I don't use Twitter or anything like that, but if you have any points of discussion, feel free either to email me or to write in the comments section of this video. Thank you.